Hello, welcome to episode 53, still continuation of mechanic dynamics episode. We are picking a question on velocity time graph to text the tutorial we did on, I think, the last three episodes. So we have a body, we start from rest and accelerate to a velocity of 5 meters per second in 20 seconds. It maintains this velocity for 10 seconds and then decelerates to rest in further 10 seconds. So we have to draw a velocity time graph of the motion, then hence calculate the initial acceleration of the body and the total distance what covered by the body. So from here, what do we do? Let's first bring out let's start with the first one, which is asking us to draw the velocity time graph. It is going to be, let's begin somewhere here. So we have the origin to be what? 0. 0 is the origin. Then we can say that this is the axis for time in seconds. This is the axis for velocity meter per seconds. So if the body starts from rest, that is from the origin, and accelerate to a velocity of what? 5 meters. So this is going to be, let's say these are 5 meters. Now it's accelerate in 20 seconds. So it means that as it moves to this place, the distance on the time is going to be 20 seconds. It maintains this velocity for 10 seconds. It means that the velocity is neither decreasing below 5 or increasing, but maintained for extra 10 minutes, 10 seconds. So 10 seconds means that from here to here is 10. Added on to this, reading from 0, it becomes what? The 30 seconds. And then decelerate, meaning reduction in velocity to rest for 10 extra seconds. So from here, it moves to 4 meters per second, then decrease all the way to the bottom. So let's say this is time, then 10, making here what? 40. Is it 10, right? 10, 10, 10. Okay, so that is what we are going to have. So this gives us the velocity time graph. Moving from 0, the origin, to a height of 5 meters per second as a velocity, maintaining that velocity for 10 seconds, then decelerating for extra what? 10 seconds. So this gives us the diagram. All right. Now for the second part of the question, we have to calculate for the initial acceleration. Initial acceleration, the uniform acceleration it has in the beginning. We have a constant acceleration as being 0. We have deceleration. So here, if I am to label the informations, you see initial velocity is going to be 0 meter per second. Your final velocity, as in the first acceleration, will be 5 meter per second. The time is going to be 20 what? Seconds. So to find acceleration, which is change in what? Velocity over time. Or we go in for the first equation of motion. Anyone you pick. You know, first equation of motion is V equals to U plus what? AT. Where the U is going to be 0. So V equals to AT. To find A, we divide it by what? By the T. So I always say that my acceleration is V minus U divided by T. V is what? 5 minus 0 divided by 20. And that gives us 5 divided by 20. And I'm sure 1 over 4. So we have 0.25 meter per second what? Squared. So the initial acceleration taken by the body is going to be 0.25 meter per second squared. All right. Then we are also asked to find the total distance covered. The distance covered is the area under the curve or area under the graph. So we can say that area, okay, distance covered. Let's begin with distance covered equals what? area under the curve, or better still, under the graph. And how do you find the area under the graph? You can see in the previous episode we deal with the two approach, taking the area one by one, area 1, then area 2, then we have for area 3. We add it all together, give us the final answer, or we deal with the trapezium rule of finding the area of a trapezium. So since I have indicated the areas, we can say that area 1 is going to be a triangle. Therefore, half base times height. So let's see half. What is the base of this particular triangle? It is going to be 20. The height is going to be 5. So 20 by 5, half of 20 is 10. 10 times 5 will be 50. So I have 50 meters. We are not using meter square because we are looking for distance, not the area per se. So let's see, we have area 2 is from here to here, which is a rectangle. So this is going to be 10, let's say length times breadth. So 10 times what? 5. 10 in this interval, 5 in this interval, also give us what? 50 meters. What do we do next? Let's go for area 3, which is still a triangle, half base times height, this triangle. And that gives you 1/2 times the base, which is still 10, the height, which is still what? 5. So half of 10, that will give you 5. 5 times 5, that will be 25 meters. So we can see that total distance covered is going to be the area 1 plus area 2 plus area 3, which is going to be 50 meters plus, well, the next is also 50 meters plus 25 meters. That gives us 125 meters. So the total distance covered will become 125 meters. Based on calculating it area by area of the structured diagram, we can also take the trapezium and see how that will also look like. So we can say that area, or let's say total distance, or let's say distance covered, let's just make it simple. Distance covered equals what? Area of what? Trapezium. So we can say that this is going to be half A plus B times what? The height. A is just from here to here. The distance we can get from here to here, which is going to be 10. Then in terms of the B, from here, 0, all the way to this place is going to be what? 40. So I'm going to have half times 10 plus 40 times the height. From here to that place will be 5. So this gives you half of 50, which is 10 plus 40 times what? 50. And this is going to be, if you find half of this, 25. 25 times 5. I think this is, if you multiply this, we have 100. Then this is going to be 25. So 125 meters become the total distance covered if we want to follow the trapezium rule, or we can also follow this. I think there are ways by which this can also be plotted on a graph. Similar questions will be asked. Find the acceleration for the first part of the journey, the second part, the third part. Total distance covered. All these can all be asked. I guess concept is clear. Like, share, comment, subscribe, and come back for more.